Solve the system of equations using matrices. First, we'll write an augmented matrix to represent the system, and then we're going to use a calculator to convert that matrix into reduced row echelon form. Using the calculator to get it into reduced row echelon form is a huge shortcut that takes a lot less time than algebraically performing those row operations. So first, we'll convert the system to a matrix, and to do that we need to make sure that all our x's are lined up, the y terms are all lined up, the z terms are all lined up, and the constants are all to the right of the equal sign. Since we'll have three variables, we're going to have four columns, one for x, y, z, and then also for the constants, but we have three rows. The first row is going to go into the matrix as 1 being the coefficient on x, 1 being the coefficient on y, and -1 being the coefficient on z, and then we have -1 as the constant to the right of the equal sign. To put row 2 into the equation, we have 4 is the coefficient on x, -3 is the coefficient on y, +2 is the coefficient on z, and then we have 16 to the right of the equal sign. And then to get row 3 into the matrix, the coefficient on x is 2, the coefficient on y is -2, and the coefficient on z is -3, and then we have 5 to the right of the equal sign. Now, in order to convert this matrix into reduced row echelon form, we're going to put it into our calculator. So to do that, we're going to start by selecting the matrix button, which is above this reciprocal button. So we have to hit second in order to access the matrix function, and then hit this button here. The first thing that we want to do is to edit a matrix in order to input our current matrix. So we arrow over to the edit menu, and then we select matrix A, or any of these matrices, but matrix A is the one that I usually select. Now we need to tell our calculator how big our matrix is. The size of a matrix is given by the number of rows, and then we cross that with the number of columns. In this situation, we have 3 rows and 4 columns, so we'll tell our calculator that we have a 3 by 4 matrix. Then we input the first row, and then the second and the third rows following right behind that. So we have 1, 1, -1, and then -1 again, completing that first row. In the second row, we have 4, -3, 2, and 16. In the third row, we have 2, -2, -3, and 5. I find it a little difficult to see the complete matrix in this window, so what I like to do is quit out of this matrix menu, select matrix again by hitting second and then this reciprocal button. We've already edited and put the matrix in. Now I just want to display it. So from the names menu, I'm just going to hit enter next to number 1 to pull the matrix that I have stored in A to the home screen. And then when I hit enter one more time, it displays it in a way that is easier for me to see. So from here I can double check my input. And it seems like we've correctly put it into the calculator. Now we want to convert this matrix into reduced row echelon form, which means we want to operate on it. And the matrix operators are also located under the matrix menu. So we'll say second, matrix again. This time we want to choose the math menu, which has all the operators in it. So we're going to arrow over one time to get to the math menu. And the function that we're after is the rref function. And that's close to the end of the list. So I'm going to arrow all the way down here until we come up to the function that is rref. We want the reduced row echelon form. A single ref is just row echelon form. And what we're demonstrating here in this video is the reduced row echelon form function. So we select that. And now we have to tell our calculator which matrix we want to put in reduced row echelon form. We could either do second matrix names A and pull the A in here, or since we pulled this matrix to the home screen on our calculator, it's been automatically stored in the answer variable. And so I can access it by hitting second answer, and it's a little bit faster to pull that matrix in. So now I hit enter, and then it displays the matrix now in reduced row echelon form. Notice we have 1s along the main diagonal and 0s above and below those 1s. So that's a pretty big shortcut because performing the row operations on a matrix is super tedious, especially on a 3 by 4 matrix. So we're just copying that matrix that's in reduced row echelon form. Although the calculator doesn't display it, this is an augmented matrix. And again, once we have our matrix in reduced row echelon form, this is when we want to convert back to a system of equations. Remember, this is our x column, our y column, our z column, and our constant column. So the first row translates to 1 being the coefficient on x, 0 is the coefficient on y, 0 is the coefficient on z, and then we're equal to 2 from the first row. In the second row, we have 0 as the coefficient on x, 1 is the coefficient on y, and 0 is the coefficient on z, so this just means that y is equal to negative 2. In the third row, we have 0 as the coefficient on x, 0 is the coefficient on y, and 1 is the coefficient on z, which means that z is equal to positive 1. So this is one way of writing the solution to the system. Another way of writing the solution is as an ordered triple. So that would be 2, negative 2, and positive 1. To understand what this means, it's important to know that a linear equation in 3 variables has a graph that is a plane in 3-dimensional space. So these 3 equations are 3 planes that intersect at this ordered triple. So let's take a look at that down here. Essentially, we have this scenario here where all 3 planes have intersected in a single ordered triple. That means that our system is consistent, and it also has one unique solution. But a different system could have infinitely many solutions. And that could be because all 3 planes intersect in a line, or because all 3 planes are coinciding. Essentially, they lie one on top of the other. It is possible to have an inconsistent system, which means that there would be no solution, and that could happen if we had 3 parallel planes, or 2 of them could intersect, but not all 3, which would mean that the system does not have a solution.